Welcome to another instructional video from OWL, the wise choice in fiber optic test equipment. I'm Professor Jim Powers. This video will help demonstrate how to check your FiberL4 optical power meter for proper operation using a WaveSource multimode light source. Patch cables and test equipment should always be checked prior to testing to ensure accurate and reliable test results. Usually a good time to do this is at the beginning of the testing day. In this procedure, we will be using the FiberL4 BOLT Optical Power Meter and the WaveSource multimode light source. Now you'll see that there are two patch cables here. There's this cable with a mandrel wrap, there's this other cable, and then there's also a mating sleeve that's used for this procedure. Okay, because this is multimode, this reference cable is wrapped around a mandrel per standards. Okay, the reason we only have one patch cable is because the multimode port on the WaveSource has two wavelengths in it, so we can set the reference through one test jumper. This cable will stay with the FiberOwl when it goes to its end of the fiber link during testing, and this mating sleeve is used to connect the two patch cables together for the purpose of checking them to make sure everything is working well together. One of the main things you need to make sure of with test cables is that they match the connector types that were being used. So you have to look at the connector type on top of the testers, in this case SC, and then you also have to look at the connector type in the patch panel that you're testing. Now for this procedure we'll just be assuming SC is in the patch panels, hence the reason why all of our cables and the mating sleeves have SC connectors on them. Okay, to begin this procedure, simply power on the units. Easily done. Okay, notice that the WaveSource powers onto the multimode port, and the indicator LED is red to start. That means 850 nanometers is lit by default. On the FiberOwl, we have an operating mode screen. Okay, for this procedure, we'll be using Simple Meter since that's the easiest way to do a quick basic check of patch cables. So, because Simple Meter is already highlighted, we'll just press F2 to select. Alright, you'll notice that the word under appears on the screen here. Okay, this is not a problem. The word under means that no measurable amount of light is entering the photodetector. In this case, it's because the dust cap is still on. So if you take a look at the top of the meter, you'll see there's two ports here. One says detector, one says light source. We'll be using the detector port because this is where measurements are taken. Notice there's a dust cap here. So if I remove the dust cap, I now have a reading on the screen. Okay, what this happens to be showing me is the amount of ambient room light coming in from the ceiling lights. Okay, this is not a problem. This is what happens when room light is entering a photodetector on a power meter. Okay, so the next thing we want to do is connect our mandrel wrap reference cable. So we take the dust caps off, and we plug them into the multimode port on the WaveSource, which is on the left-hand side, and also to the detector port on the power meter, or the FiberOwl, which is also on the left-hand side. Okay, now you see that we have a reading of minus 19.92. Okay, this is actually right about where we need to be. Our target value for multimode testing is around minus 20 dBm. You'll notice minus 19.92 is very close to that. Okay, you're not usually going to be right on minus 20. It could be a little higher, a little lower, but as long as you're close, this patch cable is fine. Okay, really what you want to make sure is that you're not falling below minus 21 dBm. If you do so, there may be other issues with the cable that prevent it from being usable for testing, but in this case, this patch cable is fine. Okay, now we want to make sure that our 1300 nanometer wavelength is also okay. So what we do is, and the nice thing about the WaveSource and the FiberOwl, when used together, they have an auto mode. Okay, so if we just press the auto button on the FiberOwl, you'll notice it says auto on, and now you'll see that the wavelength is switching between 850 and auto. Okay, what this means is that the fiber owl is waiting for an auto testing signal but has not gotten one yet. Okay. What we can do is just switch the wavelength on the light source. You'll see it flashes a little bit and then goes to green. Green is the indicator for 1300 nanometers. Again, notice it says minus 19.82. A little higher than minus 20, but it's still acceptable. We're not falling below minus 21. Okay, so we can say that this reference cable is sufficient to use for testing. But now what we have to do is check this cable here to make sure it's also okay. The easiest way to do that is to temporarily zero out the light source reference cable. Okay, the easiest way to do this, actually what I'll do is I'll demonstrate another feature of the WaveSource here called auto mode. I'll put the light source into auto mode as well. Now this could be a little tricky, so you might have to do it a couple times, but really what you need to do is press and hold this auto button here until you see this indicator LED start flashing. Immediately when it starts flashing, you remove your finger, and I'll demonstrate that here. Okay, wait for a few seconds. You'll notice that this LED begins alternating between red and green, and also between flashing and solid. Okay, this is the activity of the auto wavelength feature of the WaveSource. Notice on the fiber owl that now you see both wavelengths on the screen. Okay, this is because the fiber owl is also in auto mode. Notice that down here it's not flashing auto anymore. It's flashing between two different wavelengths. Okay, so this is a nice feature of the fiber owl and the WaveSource line of light sources. Okay, now to temporarily zero out our tester, there's two different ways we can do this. You can either press the F2 button, see where it says 0 here, or you can press the 0 key. We'll press F2. And what it'll do is it'll ask us, do we want to set the 1300 and the 850 reference? We'll say yes. Okay, keeping in mind that this is just temporary. Now what we'll do is we'll let it go through a couple cycles of auto mode, and eventually you'll see both readings appear on the screen. Okay, what this means is that our reference cable has been successfully zeroed out. Now to check this cable, we simply remove the connector from the detector. Okay, notice that we no longer have an auto signal entering the fiber owl, so it's going to go back to one wavelength. Okay, this is normal. Again, it's a low power level. We'll see it's measuring ambient room light. Okay, we put the mating sleeve on the end of the reference cable. We take on one end of the test cable, plug it into the end of the mating sleeve, and then we finally take the other end of this test cable and plug it into the detector port. Okay. Now, again, give it a few cycles of auto testing. We will notice that eventually we will get a loss reading on the screen here, and in this case we see both wavelengths. Okay, so what this means is that we have about roughly a quarter dB of loss that we're seeing with this mating sleeve here and this cable. Okay, now is this good or not? By all means, this is actually fine. That's very little loss introduced by this mating sleeve and this patch cable. Typically, you want to keep it to about a half a dB or less. You know, if you start exceeding half a dB, that means that this cable or this adapter might be not so good, and you might want to try using a new cable. So what we've done here is demonstrated that our reference cable and our power meter test cable are fine. So now we can proceed with our measurements.
If the power level falls below the acceptable power level range, debris such as dust, dirt, or finger oil may have collected on the connector end face or in the equipment's optical ports. Thoroughly clean and inspect all connector end faces and equipment's optical ports according to industry standard cleaning procedures. Several cleaning cycles may be required. Keeping connectors and optical ports clean at all times helps to keep test equipment in good working order and proper calibration, ensuring accurate and reliable test results. When not in use, dust caps should be kept on fiber connectors and optical ports to keep debris from collecting on the surfaces of the connectors and ports. During testing, it is highly recommended to clean and inspect both connectors and optical ports every time a connection is made. Failure to properly maintain your test equipment could needlessly result in costly repairs. For example, over time, repeated connector insertions into a dirty optical port could grind the debris into the optics in an equipment port. This type of damage is permanent and cannot be repaired in the field. If the problem still exists after thorough cleaning and inspection, the patch cable may need to be replaced. Patch cables are typically rated for a few hundred connector insertions, but can prematurely wear out or become damaged if they are not properly handled and maintained. If the power level is still too low, even after patch cable replacement, contact OWL Technical Support for assistance. This has been another instructional video from OWL, the wise choice in fiber optic test equipment. For more information about additional instructional videos or OWL fiber optic test equipment in general, please visit OWL's website at owl-inc.com. I'm Professor Jim Powers. Thanks for watching.